So I want to show you a couple more examples where the first one where 0 of the second derivative is actually not a point of inflection. So let's start there. So example 4. Let's make it white. So example 4. And analyze the function. So maybe we'll look at those maxima, minima, concavity, this kind of stuff. So the function looks like this: f of x equals x minus 5 and to the fourth. And again, right? So I suggest you calculate those derivatives on your own, just for practice. And this is what I have. The first derivative is 5, and then x minus 5 to the third. So this is right after I've simplified it, and so there is a bit of factoring by grouping. I hope you can figure it out. Anyway, so that's the first derivative, and the second derivative looks like this. So I have 20, and then we have x minus 5 to the second power, and x minus 2. Okay, and let's make it equal to 0. So 20, and then x minus 5 squared times x minus 2 equals 0. Okay, so if we solve it for x, we get x equals 5 and x equals 2. Okay, so so these are not necessarily inflection points, and we will see why. We could call them critical numbers, key points. The idea is that as I said before, right, things happen at those points, right, or are supposed to happen. These are some kind of points of interest. Anyway, so this is 2. I think those critical numbers, critical points, I was making them blue. Okay, 2. And then the testing numbers were red. Alright, so we'll pick maybe here on this side. We'll pick 0, 0, or maybe 1, maybe 0 is easier, right? 0, and here 3, and 6 here. Okay, so for 0, just plugging in 0 into that second derivative, right? We're testing the function or the second derivative for 0. So we get what do we have? So if I plug in 0 here, I get negative 5, but we have a square, so that's gonna be positive, and here I'll have negative, so this will be negative. So concavity down, let me check. Concavity down is red. Okay, so negative here. So negative from negative infinity all the way to 2. Okay, and then we're checking for number 3. So I'm plugging 3 in for x, and I get positive. Okay, positive, I believe, if I remember correctly, was yellow. Okay, so plus, plus, plus. And now we're checking for 6. Okay, so 6, we're plugging in that 6 again in for x's, and again we get positive, right? So you see that number 5 is not really an inflection point. So this is just concave up, this is just concave down. Okay, so let's look at the graph just to see what's happening. So all right. So I have those two key points. So one of them is inflection point at 2, right? Because at 2, I'm looking at this number line here, right? So at 2, the concavity changes, right? So from down to up. At 5, nothing happens. So we have that information, and we also have the first derivative, right? So we could, what we could do, we could make it equal to 0, right? And we could find critical numbers, right? Those critical numbers give us possible maxima or minima, right? So it's x equals 5, or x equals positive 1. Okay, so let's put those two numbers on that graph. So we have 1, then we have 5, right? So, and then we have and that's it. Oh yeah, we have the point of inflection, which is 2. I'm going to put it on the graph afterwards. Okay, so I know that this is, I have well, I'm just gonna graph it and then we'll talk about it, and we'll get to actually using this information for graphing next section. Okay, so I'm just gonna graph that. Okay, so this is just goes like this, and then here. Okay, so that point of inflection, I think I was making it green, so that's gonna be here. So that's 2. Right, that 5 should be farther to the right, but I hope you guys understand what's happening. That critical number, right, was over here. Critical number, right? So I'm getting those critical numbers here from first derivative. And I don't want to make it too complicated, but right, first derivatives gives us critical numbers that could yield either maxima or minima, and then second derivative gives us the inflection points, right? The inflection points and concavity, right? So we have concavity from concavity down, right? From negative infinity all the way to 2, right? So concavity down was red. Let's make that graph red, right? So concavity down, red. Okay, then concavity up that was from 2 all the way to positive infinity. Right, so you see that 5 is not really point of inflection, and well, there's no sign change, right? It's all positive because I have x minus 5 squared, right? So positive. And I have this maximum and minimum actually calculated. So that point is 1,256. And think about, like, how can we get how did I get that 256? Where did I plug in that 1? Right? Think about this. And then the other one is 5. This is 50, right? Obviously, so 5, 0 is that point here. And then this point was that inflection point 2,162. Right, so to get the y values, obviously, and I'm talking about these values, this one, and you plug in that x value into the original function, right, to get the y values. Okay, so we have that. I hope you understand what's going on. And yeah, a couple problems for practice. So practice. Okay, so determine concavity. concavity. And yeah, the first problem is f of x. Right, so intervals, right, of concavity. And the first problem is quite easy, but still, right, go through the whole process just kind of to practice, well, that process. First derivative, second derivative, right? X squared minus x minus 2. Okay, so that's the first problem. And I'll write that the solution down there. Second problem is 3x squared. So let's just write g of x maybe equals 3x squared minus x cubed. Okay, yeah, so let me give you the solutions. So the first one, and you don't need to go through this first derivative, second derivative process to get that solution, but still, right, do try to do this. You don't need to do the number line, right, because when you take the second derivative, it's just gonna be, well, I don't want to tell you. Anyway, and here, well, this one is actually, yeah, for this one, for number 2, I'd like you to do that that number line. Okay, so concavity of up for from negative infinity all the way to 1, and concavity down from 1 to positive infinity. Okay. Okay, and the next example, yeah, that was that example where the function actually changes concavity, but the point where it happens is not an inflection point. Okay, so example 5. So analyze. And again, right, we have a function, and again, I'd like you to do that, calculate those derivatives on your own. And that kind of should be becoming easy for you, right? Those calculating those derivatives. Right? Because pretty soon we'll be doing integrals, right? Integrals are much more difficult. At least for me. Okay, so negative 1 over x squared, so that's the first derivative. The second derivative, again, try to do it on your own. It should be positive, isn't it? Yeah. So it's 2 over x cubed. Okay, so when you look at that second derivative, right, we have 2 over x cubed. So we could conclude that that derivative, second derivative, doesn't exist at, so dna doesn't exist at x equals 0. So that potentially could be an inflection point, but that 0, right, is not in the domain of the function, right? So for a number, for a point to be an inflection point, and the x needs to be in the domain of the function, right? So the original function doesn't have 0 as in its domain. Okay, and well, let's graph it quickly and see what's happening. Okay, so yeah, so this is a rational, the basic rational function, and it looks like this. So we have a branch here, we have a branch here, and you see that even though the function changes concavity, right, because it's up here, you know, my memory, red is down, right? So we have concavity down here, and then at 0 it changes concavity, but that 0 is not an inflection point because inflection point number needs to be in the domain, and 0 is not. Okay, so let's make a comment here. So 0, 0 is not and inflection point. Okay. Yeah, so I gave you some practice problems. I showed you this. Okay, so let's look at right. We had this first derivative test. Well, there's second derivative test. So let's look at that. So second derivative test. Second second derivative test. And yeah, we kind of have seen it already, but let me write it again. So let f prime of c equals 0, right? So that c is a critical number. Critical number. And then if right, I calculate the second derivative and I plug in that critical number into the second derivative, I get the number that's bigger than 0. Then concave up, right, let's make it yellow, concave up, and obviously we have minimum. So second conclusion, relative minimum. Okay, so that was the first part. The second part, well, obviously if that function is, if second derivative at c is less than 0, and concave down. I believe that was red. And we have relative maximum. Maximum. Okay, so let's look at an example.